Hello, my name is Alysha Helmrich, and I'm a graduate student at Arizona State University, researching how infrastructure managers can approach design to create resilient infrastructure. I focused on how physical and institutional capacity can be altered through deep uncertainty, complexity, leadership, and biomimicry. Infrastructure, systems that support the institutions and services that maintain a functioning society, are becoming increasingly complex while working in a deeply uncertain world. Yet infrastructure systems are not the only systems trying to operate within this dynamic. So do natural systems. In this module, we are going to take a look at resilient characteristics of infrastructure and natural systems. First, let's look at natural systems, where resilience is the expected or unexpected disturbance a system can absorb while still functioning in a dynamic equilibrium. Biomimicry, or emulation of nature and design, has provided inspiration to designers for a very long time. Oftentimes, we see emulation on a form or process level. However, we can also mimic ecosystems. In 2013, Biomimicry 3.8 developed a list of characteristics that contribute to the resilience of natural systems called life's principles. There are 6 life's principles with various sub-principles. Let's take a look at those now. First, there is evolve to survive, defined as the ability to continually incorporate and embody information to ensure enduring performance. Notably, evolution, or nature's design process, does not have an intended outcome that allows survival. However, this principle emphasizes that a system must learn through strategies such as replicating success, integrating the unexpected information, and reshuffling knowledge. Second, natural systems adapt to changing conditions by appropriately responding to dynamic contexts. They do this by incorporating diversity, maintaining integrity through self-renewal, and embodying resilience through variation, redundancy, and decentralization. Third, we see an ability to be locally attuned and responsive. Integrating with the surrounding environment through tools such as leveraging of cyclic processes, using readily available materials and energy, utilizing feedback loops, and cultivating cooperative relationships. Fourth, natural systems have the ability to integrate development with growth. Biomimicry 3.8 attributes self-organization, bottom-up approaches, modularity, and nested components towards the natural system's ability to do this. Fifth, systems should be resource efficient, skillfully and conservatively taking advantage of resources and opportunities. Natural systems use low-energy processes and recycle all materials. They also use multifunctional design and fit form to function. Sixth and last, natural systems use life-friendly chemistry by breaking down products into benign constituents, building selectively with a small subset of elements, and doing chemistry in water. These 6 principles bring insights into design strategies that have proven successful within living systems towards withstanding and adapting to stresses and shocks. As Park and others recognized in a 2013 article, resilience is not a design characteristic of a system, but an emergent property of a collection of design choices. Therefore, by integrating characteristics of natural systems that have proven to lead to the emergence of resilience, infrastructure managers may be able to foster and reconceptualize resilience in an infrastructure system. To do that, we need to understand how infrastructure managers have integrated resilience into design. Resilience does not have an agreed-upon definition in engineering. However, Woods and others published an article in 2015 stating resilience as the ability of a system to respond to expected and unexpected stresses, or long-term disturbances like aging infrastructure, and shocks, such as abrupt disturbances like extreme weather events, within and beyond engineered systems design envelope through 4 concepts: rebound, robustness, graceful extensibility, and sustained adaptability. By reviewing literature, both in academia and practice, we identified recurring themes or core concepts for resilient design. In practice, infrastructure managers use core concepts such as robustness, the ability to withstand a disturbance, efficiency, redundancy, or the ability to use multiple pathways to achieve the same function, recovery, return quickly to an intended function, and success of previous experiences. Resilient infrastructure theory includes these core concepts found in practice, but the list is expanded. We see large concepts such as adaptive capacity, or the ability to change in response to new stresses and shocks, flexibility, the ability to meet changing demands, and agility, the ability of physical and institutional systems to maintain functionality and uncertainty. These overarching themes and end goals for resilient infrastructure are supported by more core concepts, such as anticipating, when a system can integrate knowledge to predict disturbances, cohesion, utilization of unifying forces and feedbacks, diversity, the ability to have multiple functions and strategies, graceful extensibility, or opportunity for infrastructure to respond to disturbances beyond its design envelope, holistic design, or incorporating multiple perspectives in the design phase, innovation, integrating something new, whether adaptive or transformational, learning, the ability to learn from experiences within the system or from similar systems, resourcefulness, the institutional capacity to respond to a disturbance, and lastly, sensing, recognizing and understanding new stresses. Infrastructure resilience theory encompasses infrastructure resilience practice, and additionally, infrastructure resilience theory advocates agile and adaptive infrastructure. However, it fails to provide the guidance infrastructure managers need to implement such designs in practice, showing the importance of science communication and a need for its application. Thank you.